So today we will do the lab program, that is lab program 5. Here what we are trying to do is the part A program, and this program is written in assembly, that is using ARM instruction set. Now uh, the program is to find the square of a number 1 to 10 using lookup table. Here we are not actually writing a program to find the square. We have already found out the square and we are going to store it in the memory, and that we are going to use it as lookup table. So now 1 to 10 we have to find the square. So now before starting the program, let us take up the lookup table here. So here if you are seeing the lookup table, this is a lookup table. So you're finding out the square of 0. What is square of 0? You're already finding out the square of 0 here. That is a result. That is 0. And next one is square of 1. It is 1. This is square of 2. So square of 2 is 4. So you're already finding the square and you're storing it in the memory. So the program is not to find the square. The square you are finding out manually and you're going to store it in the memory. And here square of 3 is 9. And the next one, square of 4 is 16, but here we are storing it in 10 because 16 is decimal. And here assembly code we work with hexa. So 16, if you divide it by 16, the quotient will be 1. That is what here 1, and the remainder is 0. This I have taught you in the class. And next one, square of 5. Square of 5 is 25. It's in decimal. Convert it into hexa. How? Divided by 16. So quotient is 1 and the remainder is 9. So in this way you will find out square of 6, 7, 8, 9, and you will store the corresponding hexa value. So as you know that this is a lookup table and this is a memory. In the data segment, you know that we are going to store the square of the numbers from 0 to 10 in hexa. So table 1 is actually a lookup table in the data segment. This is something kind of an array declaration. It's a kind of array declaration. You know, first whenever we start writing any program in ARM, you know that we will start with the code. So let's come back. So this particular code is an actual program. After ending the code, that is the actual program, we will start declaring the data, that is the variables or arrays or the initialization. So here we are going to declare, so DCD, it is going to declare the double word here, that is 32-bit value. So table 1 is an array. Table 1 is an array. So in the first position you're going to store 0. In the second position you're going to store it as 1. So in this way it goes on for all the values. So for all the values. So in the memory this will be stored. So let me just show you how the memory is organized here. Now let us assume the starting address of the memory is 0000. Now what is the first index we are storing? 0000. So this, if you have clarity, programming is very simple. Only thing you have to know the memory organization here. That is the main important thing you should know in this program. So this is actually, you know, the lower byte. How many bytes? 32 bits, and it is 4 bytes. So this is 1 byte, next all these bytes. So the lower byte always goes to the lower address. You know this concept very well. So 0, you're seeing here, this is 00, 00, 00, 00. So all these things, how many bytes? 0th location. So the memory, assume the starting address of the table 1 is 000. So this is a 1. So in the 0th location, what is the data stored? 00. In the first location, the next 00. 00. So all this overall, how many bytes? 4 bytes is stored here. Now let's go to the next byte. What is it? 00001. Which is the lowest byte? 01. So that will go to the lowest address. So 01 will come to the lowest address and followed by the remaining zeros. So let's go to the next one. 00004. So 04 is the lowest byte. So again it occupies the lowest address, and the remaining three bytes of zeros will occupy the consecutive addresses. The next, it is 9. So what are you seeing here? So 9 followed by 3. I hope you understood the memory organization here. If you have clarity over this, we will go to the actual programming. So we are done with the an array declarations in the data segments, and we know how it is stored in the memory. Now let's come back to the actual program. What is the logic we are using here? So area, square, code, read only. So all of you know this particular area is actually a code segment, and the name of this particular code is square, and it is read only. So entry, this marks the first instruction to execute the keyword. Start is a keyword for all the assembly code. Now LDR. So all of you know what is LDR, load instruction. So when I write equals table 1, what is table 1 here? It's an array. So that starting address of that, because it's equal, so loads the starting address of the lookup table. So assume that table 1 starting address is 0. Assume 0000. This is what I took. Assume that is the address. Okay. Store that into R0. So R0 is holding what? The starting address of table 1. Now let's go to the next one. LDR R2. This particular address, I'm giving an address, specifying the address directly here. So what does this address contain? Here in this program, for which number I want to find out the square, that number will be stored in this memory address. This is a memory address. So I'm going to directly put a value into this particular address. Okay. So for that purpose, I'm going to use. So R2 right now is holding what? The address. So the contents of that. So 4000, this is loaded into R2. Now, so what is it? R0 is holding, R0 is holding the starting address. R2 is holding the memory address in which the number will be loading to find the square. Next, LDR R1 comma R2 in square bracket. So the contents present in this memory address. So now let's assume. So what is this? 40,000 something, 4000. So this is a memory address. The content present in that, what is the content? Assume I want to find out the square of the number 3. That I'm going to put it in this particular address. That will be loaded to R2 here. So R2 will be holding what? R2 is holding the address. The content present in that address is 3. That is loaded to R1. So R2 is holding this address. What is the content present in that? 03. So when I write like this, so 03 is there in R2. The content present in that is loaded to R1. So now what R1 is holding? R1 is holding 3. Means I need to find the square of 3. What is the square of 3? It is 9. And that is there already in the memory location. Now we have to go to that appropriate memory location, and we have to fetch this number, and we have to display the result. The input is 3 and the output it should display as 9. So we have to go to this memory location 9. How is that possible? What is the technique we are using? R1 is holding the number 3. So we will take that R1 3 and we will do logical shift left twice. So this logical shift left instruction you have studied in module 2. Same concept, scaled indexing. So R1 we are going to take 3 and that we are going to scale it towards left 2 times. This is the logic we are going to apply. So 0, 0, 3, the 1, 1. So this is the actual value. So R1 is holding what? 3. So shift towards left once, you will get this value. Again, I have to shift one more time because this is the actual number. I have to shift twice. If I shift twice, I'm going to get the value 1100. This shifting concept, all of you know, left shift. So 0 will be appended towards LSB. Again, one more left shift. This 1 will come here, 1 will come, 0 will come, and 0 will be appended in the LSB. This is the value. So what is the value I'm getting? Apply 8421 code, 8 plus 4, 12, that is C. So 0C is the, in the 0C location, my data, my final result is stored that is the square of 3. So now let us see what we will be doing. So R1 is holding the 0C. Now add R0 comma R0 comma R1. So what is R0 holding? The starting address, that is 0000. So R0 is completely 0. To that, if I add 0C, where it will take R0 is holding 00. To this, add 0C. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. So now in this particular location, whatever is the result, that it is fetched and it is loaded to R3. So where is the result, final result stored? In R3. So what R3 will be holding? 9. R3 will be holding 9. So in this way, we will be finding out the square of a number from a lookup table. Program is not written to find the square. Program we are doing manually. We are finding out the square of all the numbers and we are storing it in the lookup table. Only thing, the program is written to fetch that particular number from the memory location, appropriate memory location. So this is about the fifth program. It's quite a simple program.